cathode have ionic equation. Have ionic equation, which is invariably the discharge of what? Cations to their respective what? Atoms. Examples, cations always migrate or are being attracted to the cathode. Cations are positively charged ions, including this non-metal. Most cations are metal when they are discharged, but hydrogen is the only one that is a non-metal. Went to electrolysis, and whenever you observe a gas around the cathode, that gas must be what? Hydrogen what? Gas. So let's look at how to write the cathode half ionic equations for the three stated here. Let me take sodium. This sodium plus. The zero number here is what? Plus 1. They will not write 1. So to accept 1 electron and it become what? Discharge is sodium atom. Sodium atom. So this is the cation and this is the sodium atom. And likewise this. The oxidation number of calcium is plus 2. So you accept 2. Plus go with plus. And you go with what? This. That's calcium atom. And likewise aluminium. Aluminium will also accept 3 electrons. And you get aluminium atom. Right? Now the general formula for all these are you represent all of these with X. Alright, what? Plus N or N plus. That plus represents what? They are all catapositively charged. The N is the number of what? The oxidation number, right? This is the oxidation what? Number. So for this very one, it's going to be what? Plus N, right? And E is there, and that gives you X. So if you have 2 or just N equal to 1, and you have here is N equal to 1, zero number is 1, then you have just what? Plus. Then plus N will give you this. I'm trying to generalize it now, right? To know others is just to know that if all of these presented with what? Capital X and N is the oxygen number, and this is the charge because they are all positively charged. So this is invariably it. So we oxygen number, like elements in group 1, the cations are having 1, 1, represent all group 1. So they will accept 1 electron, that's 1 electron, and that would be what? Since N is 1, so it will be this, and that is that. So N in group 2, if N is 2, that's X2 plus, you know how what? Plus 2E, and that's X. Hope you are getting it. And likewise those in group 3. Those in group 3, N, what 3 you have? X, 3 plus. So this will also accept 3 electrons. So all of them become what? Discharged at their respective what? Atom. This for group. This group 1. This for group 2, and this is what? Group what? 3. Right? All group 1, group 2, group 3 are discharged respectively as this. Right? New element in group 1, those in group 1, you know them. When I say group 1, I'm referring to this periodic table. This group 1, this group 2, and this group 3. Right? If I start here with lithium, that's beryllium, and this is boron. Talk about sodium, magnesium, aluminium. So they become like those in group 1. You have X plus them. Those in group 2, you have X2 plus, and those in group 3, you have X3 plus. So their discharge depends on their oxidation number. So their discharge depends on their oxidation number, right? So don't forget that is lithium, sodium, francium, potassium are discharged the way I have explained it, and likewise beryllium, magnesium, calcium, aluminum, and the rest in group 3. So don't forget the discharge of what cations. This general represents it, right? Anyone giving to you, you should be able to do it, just as I have explained with these ones, as you can see, right? The N there is the oxidation number. The N there, the N I've used here, N equal to oxidation number or charge on an ion. Don't forget the charge. So the number of electrons accepted depends on the oxygen number or the charge on an ion. So very, very important. So this is how you discharge cations, and this is the cathode half cell equation. Cathode half cell equation, right? Cathode half cell equation, right?